In this presentation, we're going to continue on with the normal distribution question from Business Statistics from summer 2011. So in the previous presentation, we've done questions 1 and 2. So now we're going to look at question 3. And a reminder, a publishing house produces assembly manuals for kit cars. The number of manuals sold each year is known to be normally distributed with a mean of 500. Let's make a note of that. Mean of 500, which is to say mu equals 500, and a standard deviation of 50, which is to say sigma equals 50. Now we're looking at this question here in particular. What is the probability that the number of manuals sold will be between 450 and 550? Well, first off, let's let x be the number of manuals sold. So that's the variable of interest, and what we're interested in is the number will be it will be between 450 and 550. So this is what we're particularly interested in, between 450 and 550. Now I didn't do it in the last question, although I probably would have helped a little bit. But what I'm going to do here definitely is draw out the bell curve. So it helps us visualize what the question we're actually being asked to solve. So this is the bell curve here, and the mean here is 500, and what we're interested in is the probability of being between 450 and 550. So let's say this is 450 here and 550 here. Okay, now my sketching isn't great, but I think you get the idea. Now what we're particularly interested in was what is the probability that the number of manuals sold will be between 450 and 550. So this area here can be represented on the bell curve by this region here. So let's try and paint that in a little bit better. So that's the region of interest that we want to compute. There we go. So that's it there. So it's that pink region there, and what we're particularly interested in is this is the between x is 450 to 550. So one approach we could take is actually to find out the areas that are outside. So for example, this red area, and we'll find out the probability of this green area. These are actually much easier to find. The idea is that the total area under the curve is 1. So if we find out this area here, the probability of this area here, the probability, and this area here, and subtract from 1, it's actually a very simple approach. So the green area, I'll call this area 1 here. Area 1 is the probability of x being greater than 550, and area 2, this region down here, is the probability of x being less than 450. So if we find out the difference, we'll be able to solve the problem pretty quickly. Okay, so we have to find these two regions here. Actually, I'll put a bit of color coding in. So this is the green area, and this is the red area, just to sort of help us visualize or get a proper sense of what we're doing. So I'm going to move to the next slide here, and we look at the probability of x being greater than 550. We'll do the first one next, or area 1 next. So probability of x being greater than 550. So the first thing we do is compute the z-score, and that is equal to, the z-score is z, small z equals x minus mu all over sigma. Okay. Now up at the top, we remember that mu is 500 and sigma is 50, and here x is 550. Small x is 550. So that's equal to 550 minus 500 all over 50. That's 50 divided by 50. That's equal to 1. So what we're saying is the probability of x greater than or equal to 550 is equal to the probability of a z value being greater than or equal to 1. And just in case you've forgotten, how do we solve this? We go to the tables. Okay, so we go to the normal tables, and in for your course it should be table 7 of your statistical tables. So, okay, let's have a look at the tables there. So, let's just sort of draw a rough sketch. So what we're interested in is the probability of z being greater than or equal to 1.00. It's best to write it to 2 decimal places. So, let's draw a sort of quick sketch of the statistical tables. This is just a sort of segment. And those are the columns, and now we'll look at the rows here. Okay, so this is, let's say this is row 0.9, this is row 1.0, and this is row 1.1, and so on, and there's more down underneath it. And suppose here we have 0.00, 0.01, and 0.02, and then there's more columns there after that. What we're interested in is this cell here. Okay, and that is equal to 0.1587. So 0.1587. Okay. Again, just to be clear, the row number is, plus the column number is 1.0 plus 0.00, and that is equal to 1.00, which is what we have up here. This is what we're looking for. So that's how the tables works. So the answer is 0.1587. So probability of x being greater than 550 is equal to the probability of z being greater than or equal to 1, and that's equal to 0.1587. Now, what about the probability of, so that's area 1. So what about area 2? Probability of x less than 450 is equal to, actually I'll just put it a bit back in the color coding there again so you can look over it again. That was the green area we're looking at, and now we'll look at the red area. So that is equal to the probability of a z-score being, of what z-score? So 450 minus 500 over 50, that's minus 50 over 50, that's equal to minus 1. So that's the probability. So the probability of x being less than 450 is equal to a z-score of less than minus 1. Okay. Now, if you recall the symmetry rule from earlier on, and a very important rule here, the symmetry rule states that, this is the symmetry rule here, I'll just write it down here quickly. For some constant value k or a, probability of z less than or equal to minus a is equal to the probability of z greater than a, greater than or equal to a. So what we could say here is that that is equal to the probability of z being greater than plus 1, and we know that one already. That's 0.1587 as well. So we know we know both areas now. Okay, so we can actually just piece it all together now and get our answer. Let's go back here a second. Sorry. So let's just draw our curve here now. Again, so make it a bit bigger this time. So what we were interested in is, this is the 500. This is 550. This was 450. Now we know the we'll actually put in the z scores beside them. So this is -1. That's always 0, and that's always 1. So those z scores. The x values there on that side are in blue. So what we found was that this area here was 0.1587. This area here, the green area, was also 0.1587. So what does that mean this area is here? That's equal to 1 minus 0.1587 plus 0.1587. And that is, so it's actually, you add these two together and subtract from 1. The answer to that, therefore, is 0.6826. Okay. So the answer to the second one is, what is the probability that the number of manuals will be sold will be between 450 and 550? The answer is 0.6826. And that ends this presentation.